Howdy, AP PreCal. It's Miss Kosh. I wanted to work the last three problems on our review sheet in front of you because I didn't want to write down too much. It's the long and the short of that. So let's look at this first one. All I have done on my calculator is I have entered in the table under statistics. If you remember, so one of the things that this is going to ask us to talk about is the residual plot. So if you remember, if you go to setup when you're inside statistics, the second thing down is the residual list. And I can change that, the residual, to put in a list is basically the idea. Since I have my X values in list 1 and my Y values in list 2, I'm going to put my residuals in list 3. So I'm going to turn that on right here. Keep in mind, I won't tell you how to do that during the test. So hopefully you remember. And so this one is telling us we've got this data where Ishan ran a linear, an exponential, and a logarithmic regression on the data, and we need to figure out which one works best, and we're looking at the residual plots. Okay, so let's think through this. When we go to graph, I'm going to set my graphs while I'm thinking about it. The first graph is going to be my scatter plot where my X values are list 1 and list 2 are my Y values, and that'll just be the data. Then what I want to do is I can come over here to graph 2, and I want it to be list 1 is my X values, and and then the Y values I want to be list 3. List 3, so that this would be the residual plot. And so I just have it set up, and I'm about to do 3 types of graphs for 3 different problems, and it's set and ready to go. So now I can graph this first one. And maybe that's linear, maybe that's exponential, I'm not real sure. So what we'll do is we'll calculate let's see, we're gonna come back over here. We'll start with linear. So AX plus B, here's our graph. I can copy this if I'd like to into Y1, so there it goes. I can draw it if I wanna see it. And here's the graph. It's great and wonderful. But what I really care about, I can exit out again, exit, and now my residuals have shown up here in list 3. So let's graph 3. Oh, and when we look at those residuals, we see pretty quickly that is a pattern. So the linear is not the best model for this data. Okay, so now we're going to calculate. Let's do we have log and exponential. We'll do the exponential. We'll do a times b to the x. Data is in use. Well, that's interesting. I've never seen that. I'm in the wrong world. My bad. Okay, so we have to exit out. That was fun. Now you can see what to do with that. If I go to graph 1 again, so I need to look at the original data. I was trying to run a regression on my residual plot, which is a little not what I want to do, a little ridiculous. Okay, back to the original data. I can go calculate, come back over to my exponential a times b to the x. Here it is. I can copy it, so I'm going to copy it while I'm there just so I don't have to do it later. But I'm going to just copy it right on top of the last one because we decided it wasn't linear. We can draw that, and that fits a lot better. But the important thing is what am I doing? The important thing, exit, that's what I was trying to do, is to come back here and to look at the residual plot. And so on this one, the residual plot of my exponential function is random. So it appears to me that we want this, we want to use the exponential regression. So we're going to use the exponential, but let's write down that equation really fast. Where we calculate, we can calculate it again, exponential a times b to the x. Oh, I did it again, you guys. Okay, graph 1, calculate, exponential, and now this is 52.555, well, this would round, whatever, times b is 1.3150 to the x. Okay, so we're going to hang on to that equation. We did copy it into y equals already. Let's exit out. Let's graph this again and then calculate the logarithmic regression. So we can copy it. Let's copy it not into y1 because we know we want y1. We don't know that we want this equation. When I draw this, okay, that doesn't appear to match it at all, but let's look at when we exit back out. Notice we've got new residuals here. We can do graph 2, and those residual values seem to have a pattern as well. So sure enough, the exponential is the best for this. So I'm too lazy to sketch all these things for you, but you've been watching on my screen. So we're just going to call that the sketch. So use our model. We now want to use the model to predict f of 10 and when find when x equals, find x when f of x equals 150. So now I'm going to leave the world of statistics and come into the graph. And I can turn on the top equation. I don't need the bottom equation. I'm just going to delete it, get rid of it, because remember how bad the logarithmic one looked? So now when I draw that, oh, that's interesting. The window didn't match what I expected, but if I come back to statistics and I graph this again and calculate the exponential regression, do I need to do that? Now when I come back to graph, usually it makes the window match that. Ah, there we go. Okay, so it remembered the previous window that we had. I don't know why it changed so much, but there we go. Because I did the residual graph. That's why it changed. GSolve. So we're going to come over and find YCal. So we want to know when f of 10. So when we're going to plug in 10. Oh, okay. We need to change our domain. So I'm going to come to window. Exit out of here, shift window. We need x values bigger than 10. So 11 is bigger than 10. Now when I draw this, I can do GSolve, come over to YCal 10. And I can't see it on the graph, but it's about 812 point, you can see what I'm doing, good, 6522. Okay, and then the other question is find what the x value that corresponds to 150 for a y. So I can, I didn't need to do that, but whatever. I can GSolve and come over to XCal. I have a y value of 150. And so now f of about 3.8298 is about equal to 150. Okay. Well, that was a 7-minute video. Come back and watch. I'll do another video for number 39 and then probably a third video for number 40. So I will see you in the next video.